In the second example, we are looking for the z-score that has 10.75% of the distribution's area to its right. So it does not have a lot of the, area under the curve to the right. It only has a little bit more than 10% of it. So that would look something like this. Where over here off to the right in that shaded region is only 10.75%, whereas a decimal 0.1075 out of 1, 0.1075 out of 1 off to the left. Off to the right, excuse me, because it's to the right here. And what we are interested in finding is what is this z-score? Okay. We have already seen the first example worked out using the standard normal distribution table. This example could also be worked out that way, but the problem is that the standard normal distribution table only shows us left area. So if we went looking in the table, we would have to be looking for whatever this green area is off to the left, because the standard normal table only gives us left area. But we could find the left area because we know that the left area and the right area the green and the red must all come together to give us 1. So the green is whatever is left after I take away 0.1075 away from 1, and I'm left with 0.8925. So we could work out example 2 the same way we did example 1, where we're now looking for a left area of 0.8925 in the calculator, in the standard normal distribution table. We would go to the table here. We would look for 0.8925. I'm looking. Here we go. And I can see right here my answer is 1.24. 1.24. So that's a demonstration of how you could use the table, but I want to show you also how you could use your calculator to calculate that z-score. Now we know that we can use the normal CDF function in the calculator to give us the area. We know that we can use the normal CDF function in the calculator to give us the area, but there's a different function in the calculator that we can use to give us the z-score. So I've already hit second, and I'm still going to hit bars to get to distribution. But this time I want to go down to number 3. I want to go to inv norm because I'm really inverting the normal distribution. We're doing these problems backwards. So I've hit enter. Notice now they're asking me for an area. They're asking me for an area. And the area they're asking me for is the left area. So I will need to put in 0.8925 because we can see that's the left area in green. This is the standard normal distribution, so mu is still 0 and sigma is still 1. I hit enter 2 times and I still get 1. It's gone now, but I still get 1.24. I will take a little screenshot of this and paste this into our notes here. So now we have seen copy. Now we have seen this example worked out using the standard normal distribution table and also using the calculator where we use the inv norm function on the calculator. So if we're going from it's a quick little summary. If we're going from an area, to a z-score on the calculator, you use inv norm and you enter the left area. If you're going from a z-score to an area, which is what we were doing in lesson 15, you use normal CDF. And you enter bounds. You enter upper bounds and lower bounds. And again, so like this second bullet point is not what we're actually talking about in this lesson. It's just a quick little refresher because I really want to make sure you all are seeing how lessons 14, 15, and 16 are all tied in together with each other. So the answer for this question is that z is equal to 1.24. And I have shown you how you can get that on the calculator, and we also saw very quickly how we could have looked that up. Not this one. Where did it go? What were we looking for? 0.8925? I know I did it over here. But how we could have found 0.8925, 1.24 using the standard normal table as well.